Main article, C#. This article describes the syntax of the C programming language. The features described are compatible with .NET Framework and Mono. Basics. Identifier An identifier is the name of an element in the code. There are certain standard naming conventions to follow when selecting names for elements. An identifier can start with an underscore, start with a $sign, dollar, contain an underscore, contain a numeral, 0123456789, contain both uppercase and lowercase Unicode letters. Case is sensitive. An identifier cannot start with a numeral, start with a symbol, unless it is a keyword, have more than 511 chars, contain its sign in between or at the end. Keywords. Keywords are predefined reserved words with special syntactic meaning. The language has two types of keyword: contextual and reserved. The reserved keywords such as false or byte may only be used as keywords. The contextual keywords such as where or from are only treated as keywords in certain situations. If an identifier is needed which would be the same as a reserved keyword, it may be prefixed by the @ character to distinguish it. This facilitates reuse of .NET code written in other languages. Using a keyword as an identifier. Literals variables Variables are identifiers associated with values. They are declared by writing the variable's type and name, and are optionally initialized in the same statement. Declare. Assigning. Initialize. Multiple variables of the same type can be declared and initialized in one statement. Local variable type inference. This is a feature of C 3.0. C 3.0 introduced type inference, allowing the type specifier of a variable declaration to be replaced by the keyword var, if its actual type can be statically determined from the initializer. This reduces repetition, especially for types with multiple generic type parameters, and adheres more closely to the dry principle. See also, type inference. Constants Constants are immutable values. Const. When declaring a local variable or a field with the const keyword as a prefix, the value must be given when it is declared. After that it is locked and cannot change. They can either be declared in the context as a field or a local variable. Constants are implicitly static. This shows all the uses of the keyword. Read-only. The read-only keyword does a similar thing to fields. Like fields marked as const, they cannot change once initialized. The difference is that you can choose to initialize them in a constructor. This only works on fields. Read-only fields can either be members of an instance or static class members. Code blocks the operators are used to signify a code block and a new scope. Class members and the body of a method are examples of what can live inside these braces in various contexts. Inside of method bodies you can use the braces to create new scopes like so. Program structure. A C application consists of classes and their members. Classes and other types exist in namespaces but can also be nested inside other classes. Main method whether it is a console or a graphical interface application, the program must have an entry point of some sort. The entry point of the C application is the main method. There can only be one, and it is a static method in a class. The method usually returns void and is passed command line arguments as an array of strings. A main method is also allowed to return an integer value if specified. Namespaces Namespaces are a part of a type name and they are used to group and or distinguish named entities from other ones. A namespace is defined like this. Using statement the using statement loads a specific namespace from a referenced assembly. It is usually placed in the top of a code file but it can be placed elsewhere if wanted, for example inside classes. The statement can also be used to define another name for an existing namespace or type. This is sometimes useful when names are too long and less readable. Operators. Operator overloading Some of the existing operators can be overloaded by writing an overload method. These are the overloadable operators, Assignment operators are combinations of a binary operator and the assignment operator and will be evaluated using the ordinary operators, which can be overloaded. Cast operators cannot be overloaded, but you can define conversion operators. Array indexing operator is not overloadable, but you can define new indexes. See also, operator overloading. Conversion operators equals. The cast operator is not overloadable, but you can write a conversion operator method which lives in the target class. Conversion methods can define two varieties of operators, implicit and explicit conversion operators. The implicit operator will cast without specifying with the cast operator, and the explicit operator requires it to be used. Implicit conversion operator. Explicit conversion operator. As operator, the as operator will attempt to do a silent cast to a given type. If it succeeds, it will return the object as the new type. If it fails, it will return a null reference. Null coalesce operator equals. This is a feature of C 2.0. The following is shorthand for, meaning that if the content of variable if not null value is not null, that content will be returned, otherwise the content of variable otherwise value is returned. Control structures. C inherits most of the control structures of C++ and also adds new ones like the for each statement. Conditional structures equals. These structures control the flow of the program through given conditions. If statement. The if statement is entered when the given condition is true. Single-line case statements do not require block braces, although it is mostly preferred by convention. Simple one-line statement. Multi-line with else block. Recommended coding conventions for an if statement. Switch statement. The switch construct serves as a filter for different values. Each value leads to a case. It is not allowed to fall through case sections, and therefore the keyword break is typically used to end a case. An unconditional return in a case section can also be used to end a case. See also how goto statement can be used to fall through from one case to the next. Many cases may lead to the same code though. The default case handles all the other cases not handled by the construct. Iteration structures equals. Iteration statements are statements that are repeatedly executed when a given condition is evaluated as true. While loop. Do. While loop. For loop. The for loop consists of three parts: declaration, condition and increment. Any of them can be left out as they are optional. Is equivalent to this code represented with a while statement. For each loop. The for each statement is derived from the for statement and makes use of a certain pattern described in CS language specification in order to obtain and use an enumerator of elements to iterate over. Each item in the given collection will be returned and reachable in the context of the code block. When the block has been executed, the next item will be returned until there are no items remaining. Jump statements equals. Jump statements are inherited from C++ and ultimately assembly languages through it. They simply represent the jump instructions of an assembly language that controls the flow of a program. Labels and goto statement. Labels are given points in code that can be jumped to by using the goto statement. The goto statement can be used in switch statements to jump from one case to another or to fall through from one case to the next. Break statement. The break statement breaks out of the closest loop or switch statement. Execution continues in the statement after the terminated statement, if any. Continue statement. The continue statement discontinues the current iteration of the current control statement and begins the next iteration. The while loop in the code above reads characters by calling getChar, skipping the statements in the body of the loop if the characters are spaces. Exception handling equals. Runtime exception handling method in C is inherited from Java and C++. The base class library has a class called System Exception from which all other exception classes are derived. An exception object contains all the information about a specific exception and also the inner exceptions that were caused. Programmers may define their own exceptions by deriving from the exception class. An exception can be thrown this way. Try. Catch. Finally statements. Exceptions are managed within try. Catch blocks. The statements within the try block are executed, and if any of them throws an exception, execution of the block is discontinued and the exception is handled by the catch block. There may be multiple catch blocks, in which case the first block with an exception variable whose type matches the type of the thrown exception is executed. If no catch block matches the type of the thrown exception, the execution of the outer block containing the try catch statement is discontinued, and the exception is passed up and outside the containing block or method. The exception is propagated upwards through the call stack until a matching catch block is found within one of the currently active methods. If the exception propagates all the way up to the topmost main method without a matching catch block being found, the entire program is terminated and a textual description of the exception is written to the standard output stream. The statements within the finally block are always executed after the try and catch blocks, whether or not an exception was thrown. Such blocks are useful for providing cleanup code. Either a catch block, a finally block, or both, must follow the try block. Types. C is a statically typed language like C and C++. That means that every variable and constant gets a fixed type when it is being declared. There are two kinds of types, value types and reference types. Value types instances of value types reside on the stack, that is they are bound to their variables. If you declare a variable for a value type the memory gets allocated directly. If the variable gets out of scope the object is destroyed with it. Structures are more commonly known as structs. Structs are user-defined value types that are declared using the struct keyword. They are very similar to classes but are more suitable for lightweight types. Some important syntactical differences between a class and a struct are presented later in this article. The primitive data types are all structs. Predefined types these are the primitive data types. Note, string is not a struct and is not a primitive type. Enumerated types are named values representing integer values. Enum variables are initialized by default to 0. They can be assigned or initialized to the named values defined by the enumeration type. Enum type variables are integer values. Addition and subtraction between variables of the same type is allowed without any specific cast, but multiplication and division is somewhat more risky and requires an explicit cast. Casts are also required for converting enum variables to and from integer types. However, the cast will not throw an exception if the value is not specified by the enum type definition. Values can be combined using the bitewise OR operator. See also, enumeration. Reference types variables created for reference types are typed managed references. When the constructor is called, an object is created on the heap and a reference is assigned to the variable. When a variable of an object gets out of scope the reference is broken and when there are no references left the object gets marked as garbage. The garbage collector will then soon collect and destroy it. A reference variable is null when it does not reference any object. Arrays. An array type is a reference type that refers to a space containing one or more elements of a certain type. All array types derive from a common base class, system array. Each element is referenced by its index just like in C++ and Java. An array in C is what would be called a dynamic array in C++. Initializers array initializers provide convenient syntax for initialization of arrays. Multidimensional arrays arrays can have more than one dimension, for example 2 dimensions to represent a grid. See also, jagged array. Classes are self-describing user-defined reference types. Essentially all types in the .NET framework are classes, including structs and enums, that are compiler-generated classes. Class members are private by default, but can be declared as public to be visible outside of the class or protected to be visible by any descendants of the class. String class the system's string class, or simply string, represents an immutable sequence of Unicode characters. Actions performed on a string will always return a new string. The system's string builder class can be used when a mutable string is wanted. Interface Interfaces are data structures that contain member definitions with no actual implementation. A variable of an interface type is a reference to an instance of a class which implements this interface. C interfaces. Delegates. C provides type-safe object-oriented function pointers in the form of delegates. Initializing the delegate with an anonymous method. Initializing the delegate with lambda expression. Events. Events are pointers that can point to multiple methods. More exactly, they bind method pointers to one identifier. This can therefore be seen as an extension to delegates. They are typically used as triggers in UI development. The form used in C and the rest of the common language infrastructure is based on that in the classic Visual Basic. An event requires an accompanied event handler that is made from a special delegate that in a platform-specific library like in Windows Presentation Foundation and Windows Forms usually takes two parameters, sender and the event arguments. The type of the event argument object derived from the event args class that is a part of the CLI base library. Once declared in its class, the only way of invoking the event is from inside of the owner. A listener method may be implemented outside to be triggered when the event is fired. Custom event implementation is also possible. See also, event-driven programming. Nullable types. This is a feature of C 2.0. Nullable types were introduced in C 2.0 firstly to enable value types to be null. In reality, this is the same as using the nullable struct. Pointers. C has and allows pointers to selected types in unsafe context, methods and code block marked unsafe. These are syntactically the same as pointers in C and C++. However, runtime checking is disabled inside unsafe blocks. Structs are required only to be pure structs with no members of a managed reference type, for example a string or any other class. In use. See also, pointer. Dynamic. This is a feature of C 4.0 and .NET Framework 4.0. Type dynamic is a feature that enables dynamic runtime lookup to C in a static manner. Dynamic denotes a variable with an object with a type that is resolved at runtime, as opposed to compile time, as normally is done. This feature takes advantage of the dynamic language runtime and has been designed specifically with the goal of interoperating with dynamically typed languages like Iron Python and Iron Ruby. Dynamic support also eases interop with COM objects. Anonymous types. This is a feature of C 3.0. Anonymous types are nameless classes that are generated by the compiler. They are only consumable and yet very useful in a scenario like where you have a LINQ query which returns an object on select and you just want to return some specific values. Then you can define an anonymous type containing auto-generated read-only fields for the values. When instantiating another anonymous type declaration with the same signature, the type is automatically inferred by the compiler. Boxing and unboxing equals. Boxing is the operation of converting a value of a value type into a value of a corresponding reference type. Boxing in C is implicit. Unboxing is the operation of converting a value of a reference type into a value of a value type. Unboxing in C requires an explicit typecast. Example. Object-oriented programming. C has direct support for object-oriented programming. Objects equals. An object is created with a type as a template and is called an instance of that particular type. In C, objects are either references or values. No further syntactical distinction is made between those in code. Object class. All types, even value types in their boxed form, implicitly inherit from the system object class, which is the ultimate base class of all objects. The class contains the most common methods shared by all objects. Some of these are virtual and can be overridden. Classes inherit system object either directly or indirectly through another base class. Members. Some of the members of the object class, supports comparisons between objects. Finalize. Performs cleanup operations before an object is automatically reclaimed. Get hash code, gets the number corresponding to the value of the object to support the use of a hash table. Get type, gets the type of the current instance. To string, creates a human-readable text string that describes an instance of the class. Usually it returns the name of the type. Classes Classes are fundamentals of an object-oriented language such as C. They serve as a template for objects. They contain members that store and manipulate data in a real-life-like way. See also, class, structure. Differences between classes and structs. Although classes and structures are similar in both the way they are declared and how they are used, there are some significant differences. Classes are reference types and structs are value types. A structure is allocated on the stack when it is declared and the variable is bound to its address. It directly contains the value. Classes are different because the memory is allocated as objects on the heap. Variables are rather managed pointers on the stack which point to the objects. They are references. Structures require some more work than classes. For example, you need to explicitly create a default constructor which takes no arguments to initialize the struct and its members. The compiler will create a default one for classes. All fields and properties of a struct must have been initialized before an instance is created. Structs do not have finalizers and cannot inherit from another class like classes do. However, they inherit from system value type, that inherits from system object. Structs are more suitable for smaller constructs of data. This is a short summary of the differences. Declaration: a class is declared like this. Partial class equals, this is a feature of C 2.0. A partial class is a class declaration whose code is divided into separate files. The different parts of a partial class must be marked with keyword partial. Initialization: before you can use the members of the class you need to initialize the variable with a reference to an object. To create it you call the appropriate constructor using the new keyword. It has the same name as the class. For structs it is optional to explicitly call a constructor because the default one is called automatically. You just need to declare it and it gets initialized with standard values. Object initializers equals, this is a feature of C 3.0. Provides a more convenient way of initializing public fields and properties of an object. Constructor calls are optional when there is a default constructor. Collection initializers equals, this is a feature of C 3.0. Collection initializers give an array-like syntax for initializing collections. The compiler will simply generate calls to the add method. This works for classes that implement the interface iCollection. Accessing members of an instance and static members of a class are accessed using the operator. Accessing an instance members can be accessed through the name of a variable. Accessing a static class static members are accessed by using the name of the class or other type. Accessing a member through a pointer, in unsafe code, members of a value referenced by a pointer are accessed with the operator just like in C and C++. Modifiers are keywords used to modify declarations of types and type members. Most notably there is a subgroup containing the access modifiers. Class modifiers equals, abstract, specifies that a class only serves as a base class. It must be implemented in an inheriting class. Sealed, specifies that a class cannot be inherited. Class member modifiers equals, const, specifies that a variable is a constant value that has to be initialized when it gets declared. Event, declares an event. Extern, specify that a method signature without a body uses a DLL import. Override, specify that a method or property declaration is an override of a virtual member or an implementation of a member of an abstract class. Read-only, declare a field that can only be assigned values as part of the declaration or in a constructor in the same class. Unsafe, specifies an unsafe context, which allows the use of pointers. Virtual, specifies that a method or property declaration can be overridden by a derived class. Volatile, specifies a field which may be modified by an external process and prevents an optimizing compiler from modifying the use of the field. Static modifier equals, the static modifier states that a member belongs to the class and not to a specific object. Classes marked static are only allowed to contain static members. Static members are sometimes referred to as class members since they apply to the class as a whole and not to its instances. Access modifiers the access modifiers, or inheritance modifiers, set the accessibility of classes, methods, and other members. Something marked public can be reached from anywhere. Private members can only be accessed from inside the class they are declared in and will be hidden when inherited. Members with the protected modifier will be private, but accessible when inherited. Internal classes and members will only be accessible from the inside the declaring assembly. Classes and structs are implicitly internal and members are implicitly private if they do not have an access modifier. This table defines where the access modifiers can be used. Constructors. A constructor is a special method that is called automatically when an object is created. Its purpose is to initialize the members of the object. Constructors have the same name as the class and do not return anything. They may take parameters like any other method. Constructors can be public, private, or internal. See also, constructor. Destructor. The destructor is called when the object is being collected by the garbage collector to perform some manual cleanup. There is a default destructor method called finalize that can be overridden by declaring your own. The syntax is similar to the one of constructors. The difference is that the name is preceded by a and it cannot contain any parameters. There cannot be more than one destructor. Finalizers are always private. See also, destructor. Methods. Like in C and C++, there are functions that group reusable code. The main difference is that functions, just like in Java, have to reside inside of a class. A function is therefore called a method. A method has a return value, a name and usually some parameters initialized when it is called with some arguments. It can either belong to an instance of a class or be a static member. A method is called using notation on a specific variable, or as in the case of static methods, the name of a type. See also, method. Ref and out parameters equals, one can explicitly make arguments be passed by reference when calling a method with parameters preceded by keywords ref or out. These managed pointers come in handy when passing variables that you want to be modified inside the method by reference. The main difference between the two is that an out parameter must have been assigned within the method by the time the method returns, while ref need not assign a value. Optional parameters this is a feature of C 4.0. C 4.0 introduces optional parameters with default values as seen in C++. For example, in addition, to complement optional parameters, it is possible to explicitly specify parameter names in method calls, allowing to selectively pass any given subset of optional parameters for a method. The only restriction is that named parameters must be placed after the unnamed parameters. Parameter names can be specified for both optional and required parameters, and can be used to improve readability or arbitrarily reorder arguments in a call. For example, optional parameters make interoperating with COM easier. Previously, C had to pass in every parameter in the method of the COM component, even those that are optional. For example, with support for optional parameters, the code can be shortened as =extern=. A feature of C is the ability to call native code. A method's signature is simply declared without a body and is marked as extern. The DLL import attribute also needs to be added to reference the desired DLL file. Fields, or class variables, can be declared inside the class body to store data. Fields can be initialized directly when declared. Modifiers for fields, const, makes the field a constant. Private, makes the field private. Protected, makes the field protected. Public, makes the field public. Read-only, allows the field to be initialized only once in a constructor. Static, makes the field a static member. Properties bring field-like syntax and combine them with the power of methods. A property can have two accessors, get and set. Modifiers for properties, private, makes the property private. Protected, makes the property protected. Public, makes the property public. Static, makes the property a static member. Modifiers for property accessors: private, makes the accessor private; protected, makes the accessor protected; public, makes the accessor public. The default modifiers for the accessors are inherited from the property. Note that the accessor's modifiers can only be equal or more restrictive than the property's modifier. Equals automatic properties equals, this is a feature of C 3.0. A feature of C 3.0 is auto-implemented properties. You define accessors without bodies and the compiler will generate a backing field and the necessary code for the accessors. Indexes: indexes add array-like indexing capabilities to objects. They are implemented in a way similar to properties. Inheritance: classes in C may only inherit from one class. A class may derive from any class that is not marked as sealed. See also, inheritance. Virtual equals, methods marked virtual provide an implementation, but they can be overridden by the inheritors by using the override keyword. The implementation is chosen by the actual type of the object and not the type of the variable. New equals, when overloading a non-virtual method with another signature, the keyword new may be used. The used method will be chosen by the type of the variable instead of the actual type of the object. This demonstrates the case. Abstract equals, abstract classes are classes that only serve as templates and you cannot initialize an object of that type. Otherwise it is just like an ordinary class. There may be abstract members too. Abstract members are members of abstract classes that do not have any implementation. They must be overridden by the class that inherits the member. Sealed equals, the sealed modifier can be combined with the others as an optional modifier for classes to make them uninheritable. Interfaces equals, interfaces are data structures that contain member definitions and not actual implementation. They are useful when you want to define a contract between members in different types that have different implementations. You can declare definitions for methods, properties, and indexes. Interface members are implicitly public. An interface can either be implicitly or explicitly implemented. Implementing an interface is implemented by a class or extended by another interface in the same way you derive a class from another class using the notation. Implicit implementation: when implicitly implementing an interface, the members of the interface have to be public. In use. Explicit implementation: you can also explicitly implement members. The members of the interface that are explicitly implemented by a class are accessible only when the object is handled as the interface type. In use. Note: the properties in the class that extends binary operation are auto-implemented by the compiler and a backing field is automatically added. Extending multiple interfaces: interfaces and classes are allowed to extend multiple interfaces. Here is an interface that extends two interfaces. Interfaces versus abstract classes: interfaces and abstract classes are similar. The following describes some important differences. An abstract class may have member variables as well as non-abstract methods or properties. An interface cannot. A class or abstract class can only inherit from one class or abstract class. A class or abstract class may implement one or more interfaces. An interface can only extend other interfaces. An abstract class may have non-public methods and properties. An interface can only have public members. An abstract class may have constants, static methods and static members. An interface cannot. An abstract class may have constructors. An interface cannot. Generics: this is a feature of C 2.0 and .NET Framework 2.0. Generics use type parameters, which make it possible to design classes and methods that do not specify the type used until the class or method is instantiated. The main advantage is that one can use generic type parameters to create classes and methods that can be used without incurring the cost of runtime casts or boxing operations, as shown here. When compared with C++ templates, C generics can provide enhanced safety, but also have somewhat limited capabilities. For example, it is not possible to call arithmetic operators on a C generic type. Unlike C++ templates, .NET parameterized types are instantiated at runtime rather than by the compiler. Hence they can be cross-language whereas C++ templates cannot. They support some features not supported directly by C++ templates such as type constraints on generic parameters by use of interfaces. On the other hand, C does not support non-type generic parameters. Unlike generics in Java, .NET generics use reification to make parameterized types first-class objects in the Common Language Infrastructure virtual machine, which allows for optimizations and preservation of the type information. Using generics equals. Generic classes and structs can be generic. Generic interfaces. Generic delegates. Generic methods. Type parameters type parameters are names used in place of concrete types when defining a new generic. They may be associated with classes or methods by placing the type parameter in angle brackets. When instantiating a generic, you can then substitute a concrete type for the type parameter you gave in its declaration. Type parameters may be constrained by use of the where keyword and a constraint specification. Any of the 6 comma-separated constraints may be used. Covariance and contravariance. This is a feature of C 4.0 and .NET Framework 4.0. Generic interfaces and delegates can have their type parameters marked as covariant or contravariant, using keywords out and in, respectively. These declarations are then respected for type conversions, both implicit and explicit, and both compile time and runtime. For example, the existing interface IEnumerable has been redefined as follows. Therefore, any class that implements IEnumerable for some class derived is also considered to be compatible with IEnumerable for all classes and interfaces based that derived extends, directly or indirectly. In practice, it makes it possible to write code such as. For contravariance, the existing interface IComparer has been redefined as follows. Therefore, any class that implements IComparer for some class base is also considered to be compatible with IComparer for all classes and interfaces derived that are extended from base. It makes it possible to write code such as enumerators. An enumerator is an iterator. Enumerators are typically obtained by calling the getEnumerator method of an object implementing the IEnumerable interface. Container classes typically implement this interface. However, the for-each statement in C can operate on any object providing such a method, even if it doesn't implement IEnumerable. This interface was expanded into generic version in .NET 2.0. The following shows a simple use of iterators in C 2.0. Generative functionality This is a feature of C 2.0. The .NET 2.0 framework allowed C to introduce an iterator that provides generator functionality, using a yield return construct similar to yield in Python. With a yield return, the function automatically keeps its state during the iteration. LINQ This is a feature of C 3.0 and .NET Framework 3.0. LINQ, short for Language Integrated Queries, is a .NET Framework feature which simplifies the handling of data. Mainly it adds support that allows you to query arrays, collections, and databases. It also introduces binders, which makes it easier to access to databases and their data. Query syntax The LINQ query syntax was introduced in C 3.0 and lets you write SQL-like queries in C. The statements are compiled into method calls, whereby almost only the names of the methods are specified. Which methods are ultimately used is determined by normal overload resolution. Thus, the end result of the translation is affected by what symbols are in scope. What differs from SQL is that the from statement comes first and not last as in SQL. This is because it seems more natural writing like this in C and supports IntelliSense. Anonymous methods, or in their present form more commonly referred to as lambda expressions, is a feature which allows you to write inline closure-like functions in your code. There are various ways to create anonymous methods. Prior to C 3.0 there was limited support by using delegates. See also, anonymous function, closure. Anonymous delegates equals, this is a feature of C 2.0. Anonymous delegates are functions pointers that hold anonymous methods. The purpose is to make it simpler to use delegates by simplifying the process of assigning the function. Instead of declaring a separate method in code, the programmer can use the syntax to write the code inline, and the compiler will then generate an anonymous function for it. Lambda expressions equals, this is a feature of C 3.0. Lambda expressions provide a simple syntax for inline functions that are similar to closures. Functions with parameters infer the type of the parameters if other is not explicitly specified. Multi-statement lambdas have bodies enclosed by braces, and inside of them code can be written like in standard methods. Lambda expressions can be passed as arguments directly in method calls similar to anonymous delegates but with a more aesthetic syntax. Lambda expressions are essentially compiler-generated methods that are passed via delegates. These methods are reserved for the compiler only and cannot be used in any other context. Extension methods, this is a feature of C 3.0. Extension methods are a form of syntactic sugar, providing the illusion of adding new methods to the existing class outside its definition. In practice, an extension method is a static method that is callable as if it were an instance method. The receiver of the call is bound to the first parameter of the method, decorated with keyword this. See also, decorator pattern. Miscellaneous. Closure blocks equals, C implements closure blocks by means of the using statement. The using statement accepts an expression which results in an object implementing a disposable, and the compiler generates code that guarantees the object's disposal when the scope of the using statement is executed. The using statement is syntactic sugar. It makes the code more readable than the equivalent try. Finally, block thread synchronization equals, C provides the lock statement, which is yet another example of beneficial syntactic sugar. It works by marking a block of code as a critical section by mutual exclusion of access to a provided object. Like the using statement, it works by the compiler generating a try. Finally, block in its place. Attributes equals, attributes are entities of data that are stored as metadata in the compiled assembly. An attribute can be added to types and members like properties and methods. Attributes can be used for better maintenance of preprocessor directives. The .NET framework comes with predefined attributes that can be used. Some of them serve an important role at runtime, while some are just for syntactic decoration in code like compiler-generated. It does only mark that it is a compiler-generated element. Programmer-defined attributes can also be created. An attribute is essentially a class which inherits from the system attribute class. By convention, attribute classes end with attribute in their name. This will not be required when using it. Showing the attributes in use using the optional constructor parameters. Preprocessor equals, C features preprocessor directives based on the C preprocessor that allow programmers to define symbols, but not macros. Conditionals such as if, and else are also provided. Directives such as region give hints to editors for code folding. The region block must be terminated with end region directive. Code comments equals, C utilizes a double slash to indicate the rest of the line is a comment. Multi-line comments can be indicated by a starting slash asterisk and ending asterisk /. Comments do not nest. These are two single comments. Single-line comments beginning with 3 slashes are used for XML documentation. This, however, is a convention used by Visual Studio and is not part of the language definition. XML documentation system equals, CS documentation system is similar to Java's JavaDoc, but based on XML. Two methods of documentation are currently supported by the C compiler. Single-line documentation comments, such as those commonly found in Visual Studio generated code, are indicated on a line beginning with /. Multi-line documentation comments, while defined in the version 1.0 language specification, were not supported until the .NET 1.1 release. These comments are designated by a starting /* and ending */. Note there are some stringent criteria regarding white space and XML documentation when using the / technique. This code block produces a different XML comment than this code block. Syntax for documentation comments and their XML markup is defined in a non-normative annex of the ECMAC standard. The same standard also defines rules for processing of such comments, and their transformation to a plain XML document with precise rules for mapping of common language infrastructure identifiers to their related documentation elements. This allows any C integrated development environment or other development tool to find documentation for any symbol in the code in a certain well-defined way. Async await syntax. This is a feature of C 5.0 and .NET Framework 4.0. As of .NET Framework 4 there is a task library that makes it easier to write parallel and multi-threaded applications through tasks. C 5.0 has native language support for asynchrony. Consider this code that takes advantage of the task library directly. Here is the same logic written in the async await syntax. Dialects spec equals. Spec is a dialect of C that is developed in parallel with the standard implementation from Microsoft. It extends C with specification language features and is a possible future feature to the C language. It also adds syntax for the Code Contracts API that was introduced in .NET Framework 4.0. Spec is being developed by Microsoft Research. This sample shows two of the basic structures that are used when adding contracts to your code. Is used to make a reference type non-nullable, for example you cannot set the value to null. This in contrast of nullable types which allow value types to be set as null, requires indicates a condition that must be followed in the code. In this case the length of args is not allowed to be 0 or less. Non-nullable types. Spec extends C with non-nullable types that simply checks so the variables of nullable types that has been set as non-nullable are not null. If as null then an exception will be thrown. In use. Preconditions. Preconditions are checked before a method is executed. Postconditions. Postconditions are conditions that are ensured to be correct when a method has been executed. Checked exceptions. Spec adds checked exceptions like those in Java. Checked exceptions are problematic, because when a lower-level function adds a new exception type, the whole chain of methods using this method at some nested lower level must also change its contract. This violates the open-closed principle. See also, .NET Framework, C#, Mono, Visual C#. References. Archer, Tom. Inside C. Microsoft Press. ISBN 0-7356-1288-9. Bart de Smet on Spec. External links, C language specification, Microsoft.NET Framework, Mono project.